Okay, hello class. So please do cycle to day 7 entrance card and then pause and then play when you're ready. So orange juice is mixed from concentrate and water. Juice number 1 is comprised of 4 parts concentrate and 5 parts water. Juice number 2 is 5 parts concentrate and 6 parts water. So what do you think might be a strategy that works? Okay, well, so one thing that you can think of is, well, what makes up the total amounts? Well, for example, juice number 1, it is made out of 9 parts. Okay, so I'm going to just scroll down to the solutions. So juice number 1 is made up of 9 parts, 9 total parts, where 4 is concentrate and 5 plus the 4 make up the total parts. So 4 out of 9, that is the what the ratio of the concentrate is for juice number 1. And so as a decimal value, you get about 0.444444, or you can put the line on top on the single digit of 4. So number 2, juice number 2, you have 11 total parts. There's 5 plus 6 equals 11. So you have 5 out of 11, where 5 is a concentrate and you have the total parts. And so you get 0.45 with a line on top, which indicates that those digits repeat that many times. And so when you look at those two yellow values, what I'm doing is, well, between juice 1 and juice 2, if you look, there's more of the concentrate within juice number 2. Therefore, juice number 2 must be a stronger mix because there's more parts of where there's the concentrate, okay? And so juice number 2 is stronger because the juice has a higher portion of the concentrate. So that's the entrance card. And for the 3-act task with the gas guzzler activity, there are 3 little videos that you need to go over. Okay, so quickly watch the clip and then come join me again. And then you need to look at these 4 questions. All right. Okay, and when you're ready, go on to the actual questions. So what is the cost of gas? So hint, cost per liters or cents per liter. Okay, so let's go to the breakdown. So Act 1, I'm saying that with $100 for gas, I don't have enough information. So I need to know how many liters of gas was filled in order to find out how much my gas is. So Act 1, I don't have enough information. Act 2, they tell me that the cost for 14.819 liters of gas is $20.29. So I want to calculate the unit rate because when I'm doing when they tell me cost per liter, that is indicating that I need to calculate the unit rate because unit rate is how much it is per liter or per unit. Okay, and so I divided the two. 20.29 divided by 14.819. I get approximately 1.369 per liter, or in cents, I get 136.9 cents per liter. In red, I have, I'm using these arrows because they're, if I move this decimal place 2 over, I will be at cents, all right? I go through a unit conversion for when we go to question 4 more thoroughly, okay? Gas guzzler, Act number 3. So in this case, you're paying for 52.38 cents for 38.264 liters. You calculate the unit rate again, and we notice that it matches up. And the person paid 160 cents per 0.9 cents per liter, and according to our calculation, that is how much the unit rate is. So that's question 1. Question 2 is create a graph and create an equation. So what do you think? How do you think you might draw a graph? Do you think the cost of the gas is going to directly be influenced by how much gas you buy? What do you think? All right. So in order to draw a graph, what's going to help you? How do you get prepared to draw a graph? So you might say you could draw right on the graph right away, or sometimes you could use table of values. Table of values to organize your thoughts. And so if the gas is 136.9 cents per liter, that means I will make 136.9 cents per liter. I think what I meant to say was that I will pay 136.9 cents per liter. So I set up my T-chart where I have the independent values on the left, dependent values on the right. And I'm gonna do some easy numbers, meaning I'm going to do every liter, okay? And so if I get 0 liters of gas, I should be paying no money, right? Makes sense? Gas station's not going to make you pay as soon as you stop and you are right about to fill up. No, you're not going to pay at that point. It's when you put in at least 1 liter of gas, that's when you pay. The cost that you are paying directly relates to the amount of gas that you're getting. All right, so I created a T-chart and had a couple coordinates. Notice that my Y values are going up at the same rate of 136.9 every time I am putting in 1 liter of gas. This is what my table of values tells me. Onto the graph. So we've done some graphing and we always put the dependent first and then the independent. So based on my table of values, because I have my table of values, it was a bit easier to draw out my graph. So make sure my axes were labeled and then I drew my graph. So how much I pay directly depends on how many liters of gas I'm buying. All right, equation. So when I take a look, it looks like I'm paying 136.9 cents per liter. So every time I add up a liter, I'm gonna pay a multiple of that number. And so based on that, I have two versions. I have C equals 136.9x. And the only difference is in the equation on the left here, my cost is in cents. And over here, my cost is in dollars. I feel like when we're actually paying for gas, my cost is written in dollars. And so you can kind of work with either or. So that's why I provided both. That's question 2. Question 3, calculate slope. Remember, you need 2 points. What does that mean? How does it relate to the equation you developed? So recall what is slope from before. Slope is a steepness, okay, is what we saw. Is a steepness, and it's the rise over a run. It's the y2 minus y1 over x2 minus x1. And so what are some ways of finding the slope? Okay, so when I'm given a table of values, I'm gonna pick any two coordinates. It doesn't matter which ones. I usually just try to pick the easiest coordinates, meaning the easiest kind of math calculation going on. Hint, pick coordinates, order pair that you know the precise value of. What I mean is, it's more relative when I get to the graph, is that I don't want to use an order pair where I don't really know the exact cost. I do want to use exact values. Second, I apply the slope formula, and I did, and I get 136.9 for the slope. So how much my rise is compared to my run? Well, my rise is 136.9 and my run is 1. Okay, my rise is 1, and r- my rise is 136.9, and my run is 1. Okay, so that is what I see for the slope. Keep in mind that you can find the slope from the graph as well. Again, you're going to pick any two coordinates. Again, you need to make sure you're finding coordinates where you know the value of, meaning I happen to know the perfect coordinates when it's the x value is at 1 or x value is at 2. But just keep in mind, I'm not going to pick coordinates that are like in between here because I don't really know the precise values. So just keep that in mind and then apply the slope formula. And keep in mind, in this example, I went with 2 different coordinates than the previous, but I find that m is equal to 136.9. So my conclusion is I'm finding that my slope is the unit rate. It's like the rate of change. How much is my gas going to be based on the price of the gas? And so the cost to buy 1 liter of gas um, is my slope. And so let's kind of interpret this whole thing. Back there, my equation was C equals 136.9. I'm noticing that there's an overlap, okay? Um, so the slope is my unit rate and is my rate of change, okay? Does it cost for 52 liters of gas? Okay, so since the gas is 136.9 cents per liter, so that is a unit rate. So the easiest way for me is to write out my unit rate in the fraction form. I know I want to get rid of my liter signs. If I multiply the two numbers, that's going to get rid of my liter signs because liter divided by liter will cancel out. And therefore I have 7,118.8 cents is how much I'm going to pay. When you think about it back in real life, your parent or guardian is likely not paying gas in amount of cents. And so I'm going to have one more step where I do a unit conversion. So I have 2 ways. One way is like the okay, totally acceptable. I'm just using my arrows. Well, if I go to cents to dollars, my number amount should be getting smaller. And so I'm going to move my arrows twice to the left. And therefore, I'm paying $71.19. Meanwhile, for step 2, this is my preferred way because this is going to work every time and for more complicated cases. So if you can adapt it earlier on, it might be useful for you. For example, 7,118.8 cents, and it's kind of the same idea as before. I know I want to get rid of cents. That means I want to put that unit conversion in the denominator. And in 100 cents, there is $1. And so I'm going to set up my unit conversion that way with a division line. My cents will cancel out. And when I put this in the calculator, I also get 71.19. At this point, as long as you're able to get how much it is in dollars in either way, that should be okay. And therefore, it will cost $71.19 for 52 liters of gas. Okay, final consolidation summary. So what is slope? What do you think we have discovered? Slope is what? And another, when a relation is graphed, the slope describes the rate of change. Rate of change is all right, so let's go over these. So slope is the same as rate of change. How much I am paying towards gas is based on the rate of change. How much was the gas? It was a 36.9 cents per liter. That is the rate of change. Um, as you can tell from also over here, over here, my difference is in my y. That's another way of describing rate of change, right? So let's take a look. Slope is the same as rate of change. And so when a relation is graphed, the slope describes the rate of change. Rate of change is a change in one quantity relative to the change in another quantity. Therefore, rate of change is delta y over delta x, change in dependent variable, over change in independent variable. So just know that slope and rate of change is the same thing, which hopefully makes sense because when we were dealing with slope during day 6, it was more so the rise and the run. Okay. Meanwhile, when we looked at it today, it was a rate of change. How much is my cost changing per liter? But really, it's the same thing. The graph. Okay, there are two ways of looking at it. One way is as a slope. So this has a run of 1 and a rise of 136.9. So that was one way to look at it. So as rise over run is equal to 136.9 over 1. So that is what we define slope as in day 6. So that's one way. Another way to think of it is as, okay, the rate of change. The rate that, so slope is equal to rate of change, and rate of change is my change in y over change in x. Well, it's the same thing because the differences between my y is again 136.9, and the differences in my x is 1 again. And so these are really all the same thing. Okay, and going back to the note, okay, as a summary, so rate of change is equal to delta y over delta x equals change in dependent variable over change in the independent variable. But note that you're getting y2 minus y1 over x2 minus x1, which is also the formula for the slope. So the conclusion is slope is equal to rate of change.